right. Here we are, just testing the levels. I think we're good. Yeah. Welcome back. Another week. More Haskell hacking. I'm Agent Ultra, and on the stream I build stuff in Haskell for the most part. Sometimes we do other programming languages, but functional programming is the main jam. And for the past few weeks, I've been working on a client library for a database called TigerBeetle. If you don't know what that is, no problem. TigerBeetle.com. It's a financial transactions database. Small, light, written in a language called Zig. Pretty interesting development philosophy behind it and all this sort of cool technology they've been building with it. And we're building a Haskell client for it. So, yeah, let's get into the code. Last week, we got prog on a few things. So we're just getting the kind of synchronous version of the client going. So this will allow you to issue commands to the database and like wait for the results in a single thread and like wait for them synchronously. And yeah, let's remind ourselves how that looks. I'll just go ahead and set that up. I'm going to basically run my little setup script to get the database running. All right, so it's running. We're going to tail the logs just so we can see things happening. All right, so here I am tailing the logs on the left-hand side here. On the right-hand side, I'm going to pop in here, wait for that mix flake to load, which should be pretty quick this time. And we run our little test program we have, which is going to connect to the database and try to create an account. We'll probably get an error back from the server, but that's okay. I think that's where we left off last week. So we got packets like submitting to the server now through the C library. About to fix some of that, but then the C library forwards it to the database, and the database like responds to us. There we go. So we're working on parsing the response packets. So I will close this pane. Get back to this one. Haskell cat's in my lap and headbutting me. Okay, and then we're gonna just pop this back down here. Super. Okay. So I think first thing I should maybe we should just merge this the way it is. Start a new branch. This is starting to get a little long in the tooth. This feature branch. Yeah, we've been working on this for like about a month now or so. Maybe a couple months. It's been a while. Okay. I think that might actually be what I'm going to do. So all the code you're going to see here tonight is up on GitHub. I'm Agent Ultra on GitHub as well. And this is TigerBeetle HS. I'll take this out of draft. Oh, I haven't signed in yet. Oh no. Okay. Maybe we'll just continue work on the branch. That's fine too. Okay, so we gotta parse the results. Where can we do this? Source, database, TigerBeetle, client. Okay, we're in sync. This is where we're putting all the synchronous client code. Client, create accounts. So you call this create accounts function and then with client here, and then you can create a client or create an account. fact, you can create several accounts. Parsing the results. This is where we're getting the issue. Decode response here. Decode response, I believe, is in raw response. Here. Let's try to decode the response from a byte string, which is just really bytes. All right. Nothing stringy about it. And then we have this TB operation thing. We either get a decode response error or a TB response. All right, so depending on the operation, all right, we branch on it. We either create accounts. That's the one we're working on here. So we call this decode or fail function over bytes. And in the fail case, we make the error. In the create case, we create the create account result response. All right, by map takes two functions, one for each side of the by functor, which in this case is either. So decode or fail is from data.binary. So that means that we have an instance which is binary, which I think is in, I want to say it's in client in the FFI layer here. I could be wrong. Some instances of, no, there's some usage of decode or fail here. We have a binary for transfer, create transfer result, TB account, TB create accounts result. Okay, so this binary result is pretty straightforward. It's literally reading a word 32 in Little Indian format from the byte stream, and this get here. Oh, there's another instance, create counts result. Which we unmarshal, create count result. Get word 32. Which is just a wrapper around, okay, to enum and from integral. So it's trying to parse that word 32 value and just turn it into our like Haskell enum, essentially. Okay, and failing to do that. We're not getting enough bytes. Offset 128. Make error. Where's make error coming from? here. Okay, yeah, so offset and message. Okay, operation op, raw bytes, bytes. And then our parse errors, let's make parse error. Failed at offset, blah, 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 with message, blah, blah, blah. So not enough bytes to read a word 32, huh? Okay. Well, this is bytes that we're passing into that function. This is a strict byte string, so we're converting it to a lazy byte string for the parser. And our operation here. So if we're not getting very many bytes, maybe we can get the size of this byte string that we're trying to create here from our packet, TV packet data. Now this might not exactly be the right way to parse this TV packet data, possibly, depending on how it's being packed in there to begin with. Packet data size, okay. So I think we can use size of there to get the size of those. If it's got a storable instance. I think that might work. I'm just going to pop a little debug.traceM in there, and we're going to go size of bytes. A little message. Pop that bad boy in there. Oh, yeah, I gotta import that, of course. Qualified as debug. Probably. Okay, no storable for the BS byte string. Byte string might have a function for that. Fixed param builder, no, not exactly. Can I just take the length of it, maybe? Last tail in it, no, length. Yeah, okay, from bs.length. Here, length. Okay. So offset 128, parse was all at 128. That should be way more than enough bytes to store a 32-bit integer. Let's just make sure that we're getting to the right code, that we're getting to where I think we're getting to. All right, that's from data to binary. Make error. Okay, yeah. Oh, okay, yeah. We want to go down into here. Where are we? Create account result. I'm gonna put a little here. Result. Again. And then here we got TV, create accounts, result, index. And then we go here. I bet it's possibly failing on the second one. Could be both, but I'm feeling maybe data.binary is not the right instance to be using here. This is interesting. Let's just take a double check, a little looky-see at the main program. That's what I'm trying to say here. Go to main. Okay, so we just have one call to create accounts. That's it. But we're getting several parses here. We get to begin, we get x0, result okay, x0, result okay, x0, result okay, so on and so forth. Somewhere along the line we get index 1, x1, result okay, and then we encounter the parse error here. Okay, we're gonna have to look at the code or that response packet, how to parse that response packet, how that should go. Let's pop over to ye olde GitHub for the project. Let's just look at how the other clients are doing it. Response maybe? Mm. Oh, this isn't the right level. Maybe some more lower, like bindings.py. Okay, it's the packet status and So our enum create account result is what we're trying to parse. All right, we're getting result okay apparently, so this should be 0. Okay, so we got index, this should be an int, yeah, and the create account result, the enum. All right, and the reason why we have to do this parsing is because like it comes in as a void pointer with just a data size. Right, and we're supposed to match on the flag, the op flag, and parse the result based on that. Okay. So yeah, it parses a uint32 for the index, a uint32 for the result as the field. And that's pretty much it for that. So then create transfer, create accounts. Yeah. Okay. Let's check lib. Just helper functions. That's interesting. The memory referenced in bytes pointer is only valid for the duration of this callback. Edit. Copy it to a fresh Python-owned buffer and do the conversion from the raw C type to the Python data class. Okay, I think that's kind of what we're doing here in the code as well. All right, we're creating this C string here. We're creating on the Haskell side. In this await a result function, you know, we're continually looping on the mvar until we have a result put there by the callback. Which our callback is defined here. Maybe we should be doing that here. So instead of writing the packet here, we should taking the results. All right, this is the Python version of the onCompletion function. So I think that might, yeah, that probably makes some sense to do that there. I don't know if that's actually what's causing the issue here, but that's a pretty good indication that if the Python client's doing this, we should probably be doing this too. So what do? They check if the packet status is okay. If it isn't, they construct an error. And they set an error for that response. And then we get a result type. And yeah, then we do this slice. And we parse out actually all the data right here. And then we call our local onCompletion function. Okay. Okay, let's see. What can we do here? We get the packet pointer. I'm a little cat fur tonight. All right. So we get the completion callback here with the packet. And we're writing to the T-bar a thing. I guess we could technically construct... I don't think we can construct the result necessarily here. Well, actually, no. I think we could. We lift parse results up here. Just pop that up. And then we just got to turn packet. Might be a shorter way to write that now, but let's just leave that the way it is. Then here, I don't think we need a sync client T here. This has got to be IO because this is going to be running in the callback. Though we can just do M. And that gets the bytes. Get that. We decode the response with the packet operation, and then we're going to put that in there. So we peek the packet. TV response is going to be parse results of the packet. And then we're going to write not the packet, but the TV response. And then we run everything and whatever. Let's get the let's get GHCID running on this, just so we can get the type feedback. A couple of things we got to fix in here now. 46, yeah. Result, we're expecting a packet here. Sync state. Yeah. So we're gonna have to change this type here of the T-var to be, well, first a TV response. The parse gives us either decode response error or TV response. Yeah, it's probably fine, actually. We'll steal that as well. Pop that there. And this will have to be not M result, but probably just result. Then what does it mean? Here's where we get the error. Oh, this is still, sorry, I'm going ahead of myself. That's still unresolved. That's just the maybe from reading the TVAR. All right, we need maybe still in there because the TVAR can be empty for a while until we get the result back. That's right. This is redundant. And shadow binding, right, because we got a result up here. Call that response. And then we're all good. All right, let's try this. Let's see what happens. Yeah, no real difference there. It's funny, most of this is just null. Yeah, you know what? You know what? I think I understand what's going on here. I think I do. Okay, so if we go to TigerBeetle, we'll look at the bindings. Right, what do we see for create account? Like that's the enum result, but the other one. Account, create accounts, result. Index, result, right? 32, 32. The C count, C transfer, C create accounts result. It's a struct. All right. Why is it 128? All right, why is it 128 bytes long? That's my question, chat. Why is it 128 bytes long? Padding, right? Even though we're only parsing out two 32-byte values, right? Depending on the word size and how things are going to be aligned on the machine that we're running on, right? So he's going to put in some padding for those 32-byte values, so that everything's like aligned to the word boundary. 64 bytes, 64 bytes, 128. There we go. Okay, so we got to parse this as a struct, not as a literal binary string with two 32-bit integers packed into it next to each other. That's why we're running out of stuff here. I'm trying to parse to the end, and we're like, what's going on? Okay, so to fix that, we're going to go into source, database, TigerBeetle, internal FFI, count. That's probably a good place to put it. TB account, count result, that's the enum. This is what we should be using. So TB counts result, word 32, da da da. Okay, that this instance, this peak on the storable instance might do it. This is not right. This is wrong. So I'm going to get rid of that. Okay, raw response uses it. We're trying to use decoder fail. That's wrong. We shouldn't be using decoder fail here. We should be using something else. Peak. Peak. The type of peak I think returns probably maybe. It's an IO action. So it can actually return a exception. Should get it. All right, okay, so set a biomap on decoder fail here. Let's just peek at TB create accounts response. Create accounts result, sorry. Yeah, let's enable type applications. And import that. Okay, yeah, that has to be an IO where we are in a pure function here. Okay, let's back out of that. In fact, I think we should just get rid of that function altogether. Okay, and then client imports it. Yeah, here. Let me get rid of that. We're going to, from the bytes. Yeah, we'd need a pointer to there. In order to use peak. It's like we don't want to parse the, we don't want to construct the C string necessarily here, but we do want to copy that data over and parse it right away, almost. The other thing we could do, the reason why I don't like that binary instance is because of the offset is platform dependent, hopefully, obviously. Because like different alignment sizes for different platforms are going to matter, which is why the storable instance you have to give the alignment so that it knows how to like read a struct in the storable instance. But the binary instance doesn't have that. So how do we copy those bytes over and get a pointer to them so we can get the Haskell value out? Box account, we're gonna go to client, packet. We get the void pointer here. Actually, why don't we just read it out right then and there from this pointer using peak, and that should be fine. Like here. Go to that. Peak's going to be an IO action. We are in TB completion callback, which I think is an IO context, so that should be fine. Yeah, and we're doing BS pack string here, so yeah, we should be able to get the response. This function needs TM bar context results. I don't even know what type that is. It needs to be result pointer. Oh, right. Yeah, it's going to do based on the packet operation. Da, 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 da. Okay, so we need some kind of decode response type function in order to get the types lined up. But instead of this stuff, I'm going to go with packet. TB packet data. Right, because we just did like a peek here. We would not necessarily know which thing we're trying to like convert from here. Right, like if I was trying to write oh, I got it on 215 here, response here, right? Yeah, this type application actually, like we don't actually know what we want to write here because it's going to depend on the TB packet operation. But we're first, actually, before we even do that peek, we have to cast that pointer. And we have to cast that pointer also to that same type. Right, and ultimately we're going to be passing in the packet, TB packet data. Right, so the create accounts result would be like TB create accounts response, whatever. That would be the same for peak. Right, and then it knows, and then Haskell knows like where to look up the instances for these things and like how to run the code to extract that data, and then populate a Haskell record from the cstruct data. But since at this point in time, in this kind of sort of generic function, we would have to actually look at the TB packet operation to know which type to convert to. And we don't have dependent types here unless we're going to go into dependent Haskell, which we're not. We can't have, can't really use a function that returns types based on values. So we're going to need to write a new decode response to work around that. That's going to take packet.tb packet data. In fact, I could probably just take the whole packet. Right? Okay. And then when we do decode response here, instead of that, we're just going to do pure response. We'll keep it either and just never populate the left side, I guess, for now. Just because I don't know if we're going to actually, like, end up keeping this. I'm just trying to make the types go. Okay, so there we go. Now Haskell's telling us, like, we gotta write this function. Decode response. I think we should put that, yeah, maybe in raw response. Maybe we didn't need to fully remove it. We just need to decode response, TB packet to IO TB response. And then client just needs to import that. Put that back. Okay, then we go in response, TV packets not in scope. Let's bring it in. Okay, and then I'm sync stuff. It's using that decode response, is it? Just comment this out for now. I'll leave it undefined. And get rid of that one. Okay. So then I have to go back to response. Let's get here. All right, so we're gonna get we're gonna case match right off on packet. We can case match on it, or we can guard on it. And then TB operation. Okay, let's just focus on the create accounts case. All right, so if we have create accounts, we know that we need to do our peak. In fact, we probably actually just need to do it like this. We could do peak, TB, create accounts, response. create accounts result. And we get that TB, we do that after we pass the pointer from void to TB create accounts result of the packet.tb packet data. So we need data.storable or foreign storable, sorry. Import foreign storable and foreign.pointer. Right, and then, oh yeah, TB response. So that's going to be wrapped in our create accounts. Our TB response type here. So we need this constructor, create account result response. Now this should be a list of things. So I think it could be an array of these that we need to actually decode. I'm noticing like they do have indices and stuff. Let's see if this one will work. I guess if we try the pack, it'll probably fail and give us an exception. We'll see what we can do here when we get to that. We'll cross that bridge later. Yeah, so I don't know if data list has a singletons constructor. Actually, let me just check the list. Yeah, I don't think it does. Okay. No worries. We'll do this with do syntax then. That. Here. All like that. And unit. Could match type unit TB create accounts result. TB packet data. Oh, I think that must be the second argument from 2. Yeah, and then we get rid of bifunctor. Get rid of data binary. That. Okay, that all compiles. Let's run our test. Ooh, we went to one of our undefined branch. We have one here. And here. That should make sense, actually. As we call it here, yeah. Parse results. We got to fill that in. All right, so our new decode response here is an IO action. We can do IO actions and parse results. Decode response. We get the packet. And then we're just going to return your result. That doesn't work because we want it, yeah, we want to be an either here, so we're just going to turn the right result. How's that? And then we're going to lift IO this one. Raw client. We don't end up using that. Okay. Okay. Sweet. We did it. All right, let's so at least that call looks like it worked. Interestingly, it's parsing the result index as 1 and okay. So it's like 1 base indexing in TigerBeetle. But okay, so that at least that looks like it ran and executed. We got a response. We parsed the response. Okay, that part of the mission is accomplished. Let's look at the database through the REPL. Look up accounts. Is it ID 1 or ID 0? Clean. Yeah. Okay, so the REPL's claiming nothing here. What's going on? Are we connecting in the REPL to the same thing, same database? That ran, and we got that packet back that said it was okay. Let's try D0, address 3000. Should be. No accounts were found. Interesting. Okay, let's look at the logs. Okay. We have a bunch of connections. Some orderly shutdowns, looks like. Okay, 249641. Two 49641. That was just us. Okay, so if we create an account in the REPL, we're at 506 now. We'll just use their example here. Okay, interesting. I failed to create account. Create account result, linked event chain open. What does that mean? What does that mean, TigerBeetle? Linked chain open. I think that'll probably be in the TigerBeetle docs. Linked events. Okay. Oh, I said, oh, because of flags. I set a flag there to do something with linked. Okay. Okay, sorry, that was just a pepcac. I'm learning though. I'm learning. Okay. Get rid of that flag. Just create an account. Okay. Now we should be able to look up accounts, right? Okay, so we do have an account here. So we were able to create it with the REPL. I guess we kind of created it. We sort of didn't create it with the Haskell client, though, even though parse the packet back. And the server said it was okay. Are we parsing the wrong thing? Is it actually bad? It's hard to tell because it's all enums and integers. But the TB packet operation enum integer thing should tell us, because the response packet is create accounts as the operation. So yeah, I think we're handling it right. Okay, so there's an account there at 1. Ooh, this create accounts command. It takes our account.create account structs here. Account.create accounts. Okay, that's the high level. It's not in the raw layer. It's here, this one. Create an accounts packet, mapping create account over that. Create a 0 TB account. We set the TB ID, create account ID. So it should be creating the account on account 1 with the ID of 1 and a ledger 700. So presumably, if we modify our example, or this example here, will we get a different packet result? Let's try and find out. It's still saying account result okay. So I think something funky is going on. Just look at the logs. This session was 175.506. That's the shutdown. Set and verify connection. So it doesn't. It looks like the server doesn't log each command that gets run. It's just logging the connections. So it did get the connection from Haskell. And then shuts down. It looks like we got a successful response here. All right, none there. None there. That is not good, but it could still be that I'm just not quite understanding what's happening here. Create account. The ledger. So maybe they have to be unique together. So I'm basically trying to force this to give me a different response than other than okay. So that I know that at least I'm actually interacting with it. I'm not just like parsing something and like it's doing something else. And I think it's doing create accounts, but it's doing something else. And like I'm trying to parse it as a create accounts response, but it's actually a something else response. Which would be no good. Okay, so create account ledger main 700. Okay, that's what we created it within the REPL, right? ID 1 ledger 700. So if I run this now, will we get an error or like a not okay response? No, we're still getting a result. Okay. What else could be happening? The other thing is like, I don't know if they're actually, this should be 1. Like, seems like the index ought not to be 1. It seems like it would be 0. I would make it 0. So maybe it's sending us... There's all these ones here too. Code must not be 0. Ledger must not be 0. Okay. What if we make ledger 0 then? Yeah. Yeah, it's got to be... We're not quite there yet. So we're in the realm of the solution, but not quite there. Okay, because if the ledger should be 0 and we're actually sending that as 0 in the packet, then we should be getting this result. Actually, equal org show. How's this defined? Oh, okay. The manually instance enum TB credit account. Okay. Okay, cost TB carry account. Ledger must not. Okay. Okay. Right, okay, and peak, pretty simple. Peak there, the unmarshal, shouldn't be surprising. Okay, so the storable instance is fine. But maybe it's reading at the wrong offset. Packet. Let's look at you. Now, data size on this struct. Is that gonna be in bytes or in elements? So if this is gonna be packed and we can create multiple counts at once in an array, because ultimately we gotta parse out a list. Right, whereas we're constructing one here manually. Now, 128 bytes in this test program case means that we should only be getting one struct. That's enough data for one struct. So I don't think that would affect anything. But I am just... I'm a little curious about why we're getting result index 1. Maybe we're supposed to. Okay, so K is supposed to mean that it was created. And, like, we should be hitting maybe exists. Or even code must now be non-zero, because I think we're setting that to 0 as well. I'm curious about the index 1, though. Batch max, okay, yeah. So batch max, that's just an assertion. And we... derive the account timestamp. Nope. I'm looking for... Basically, I want to see if the server actually, like, when it's batching up the response, sets the result index to 1 for the first element, if there's only like one element. Or if it should start at 0, which would kind of let me know that we're actually, like... like maybe reading at the wrong offset, or like we're reading data that has been like garbage collected or something. Create accounts result. Okay, there we are. So it sets the index to request items.leng, dividing exact, the size of account -1. So that should be number of elements. So yeah, 1 would be fine. Yeah, so this is okay. This is what we expect. Okay, so we're not necessarily trying to like load, not necessarily parsing data from like a garbage collected region, but we're still getting this okay result, and it's not, I'm not seeing it in the REPL. Although both the REPL and our Haskell client are both connecting in the logs that we're seeing to the server. So why on earth is it telling us that we created the account, but we can't look up the account? We can't find it. Or if we try to create the account with the same ID as when we created in the REPL, it doesn't seem to throw an error. Like we are actually using the right client and everything. Get the TVAR, that's a completion, go back. Yeah, we're calling init client, not init client echo. Right, init client echo is just for testing your FFI boundary layer, making sure that you're calling into the library and stuff, and it just echoes out what it gets, but it doesn't actually call the server. From what I understand. So that calls init client. And I'm just going to double check that that's actually calling init client. Of course, count stuff. Emac, there we go. And let's go. Hop into the client. Init client here. And our foreign pointers, our address pointer. We take our client init here. Yeah. So we're calling the actual like client init function, not the echo one. And then we're just checking the result of that. Okay. So that's interesting. Otherwise, we get the client pointer, we get to create the sync state, and then we run our function to await the client action. We're decoding the response here. Parse results is being called only inside the callback. That's ultimately called by the C side, the C library, with this packet pointer. And then we parse the results right there immediately and put that on the TVAR. Line 33. Yeah. So that all looks good. Maybe it's not. So when we run this, this gets printed out, and then this. What's going on there? When we await result. We're just looping until that callback puts something in there. I wonder if this warning line here is actually from the TB client, the libTB client C library. And it's like outputting on our stream here that we're supposed to be controlling here. So I don't think we're printing anything out. I was thinking, in my head, I was thinking like maybe that is like even a connection sends us a response packet from the server. And that we're interpreting that. But again, we're checking the thing. Yeah, I don't know why the heck this isn't working, actually. I don't have any good theories at the moment. I go main. Right, I shouldn't be able to create one with a 0 ID. That shouldn't be able to happen, right? I should get an error for that. Compiling a new main, we're linking, we're running. And we're getting a different result index, 0, when we do that, actually. It's still okay. So yeah, I think something funky is going on here. Okay, but we are running out of time on the stream. So what I will do is I'm going to put a little comment in here. Should return an error from the server. ID and ledger be 0. So neither. Nor ledger can be 0. Okay, we'll just review this and create a little committee commit, and I think maybe we'll merge this PR and we'll create new ones to fix whatever's happening. Oh, we got some commented out code. We should get rid of that. We do remove either. Cell type, unless we catch the IO exception. Question mark. Make sure everything compiles properly. No errors. Okay, some stuff in the FFI layer that we gotta clean up. So let's go do that. says everything's fine. Let's just build the whole kit and caboodle. While that's going. Oh, okay, everything builds cleanly, so let's just continue our review. Quick little review. Okay, updated with client there, so we use parse results here in the callback. Removed. Updated await results, so we don't parse the results there. And remove the binary instance on create count result. I'm going to change this. That. And then raw response. Yeah, we just replaced decode response with our new one. Okay. Looks good. Stage. Commit. This one mostly modifies response. Well, actually more so the sync. What did we add? We added the parse response to the callback. Changed. We changed decode response to use the storable instance. And deleted or removed. Remove the binary instance on TB create counts result. Okay, we did all this because we needed to fix the response parsing for response packets, result packets sent from libtb. That's good enough. The binary instance was not accounting for struct padding in the result data. We still need to handle the other result types and clean up the parser result type. I should just go to the other operations and clean up the parser result type. And we also can't seem to verify the account is actually created. We'll need to also parse the batched results responses. This change only parses a single result. Response packet. And there we go. Okay, that looks good. Boom, boom. Boom. Okay, so if you weren't here at the beginning of the stream, and you're just tuning in, all the code you've seen for this project lives up on GitHub. I'm Agent Ultra. I'm Agent Ultra on GitHub as well as on the Twitch. And yeah. So give us a star or whatever, you know, follow along with the development if you'd like. You can also check out my stuff on the socials. You can go to agentultra.com, that's my website, or you can follow me on the types.pl server at Agent Ultra, and find links to my YouTube where I back up the VODs for this stream, and also where I post about when I'm streaming and stuff, and things I'm up to, and things I'm working on, and whatnot, what have you. So if you're on the Fediverse, follow me there as well. Give us a follow here on Twitch, or if you're watching on YouTube, a like, a subscribe, leave a comment, all those sorts of things, and let me know what you're up to and what's going on, all that sort of stuff. That's all I got for now. So may all your types check, all your monads be free. I said that a little backwards, and that's okay. Have a good one. We'll see you next week. I usually do these streams on Tuesday evenings at about 10 after 8 in the Eastern Standard Time Zone. And happy hacking out there. We'll see you soon.